Hello everybody, Mr. Rubo here. Today we're going to be doing a few pages in the notes, more logic-based videos here. So first page we're going to look at is 117. So very first question is prove that angle 1 is congruent to angle 2. That if they're congruent, then they are both right angles based on this diagram. So this is actually, instead of doing a 2-column proof here, we're going to do what is called a paragraph proof. Now, for this class, we will do more 2-column proofs than anything else, but paragraph proofs are, an option. They're actually ones that you would use more so in higher level mathematics proofs. So they're actually probably the more important ones, but they're a little harder to write because, you have to make full sentences, and sentences can be hard. With this, just like a 2-column proof, you always start with what's given. So you would say, given, and I'm writing this way too big, angle 1 is congruent to angle 2. Then, or therefore, you'll use a lot of those words for your statements. So then, measure of angle 1 is equal to measure of angle 2. Okay, so the nice thing with a paragraph proof is your reasons aren't necessarily, like, you don't have to write them as long, right? So in a 2-column proof, you have your statements that would be, like in this case, angle 1 is congruent to angle 2. Your reason would be given, but then your next line would be measure of angle 1 is equal to measure of angle 2, and that would be like if angles are congruent, then their measures are equal. As you can see, I was able to just do that in these one sentence. I was able to do 2 steps in a 2-column proof. So it's a nice thing with paragraph proofs is sometimes you can make it a little shorter. So then my next thing is the diagram shows that measure of angle 1 plus measure of angle 2 equals 180. And this is, the straight angle. We can assume straight angles, so it's okay to just say that, and that your reason is it's from the diagram. So then, because of these 2 statements, so because of the measure of angle 1 is equal to measure of angle 2, and then adding them together is 180, we can then say, therefore, again, very common word when using paragraph proofs. Paragraph proofs. Measure of angle 1 is equal to measure of angle 2, which equals 90. And so that's kind of based off the 180. But then, and we can go on and say angle 1 and angle 2 are, and this is where I was writing too big, are right angles. And instead of saying an if then, we can just say by definition of right angle. Which that's exactly what we were trying to prove, that they both were right angles. Okay. So there's our first example of paragraph proof. Sorry if my handwriting is not the greatest here. It is, my writing on stylus is not my favorite thing. All right. So there's an example of a paragraph proof. Again, it does end up being a little less writing in terms of like the if-then statements. You just are making sure you write complete sentences. Okay. So then number 2, this is kind of going more into the logic here. So if A, then B, so it's A is our condition and B is our conclusion. We want to write the converse. Well, the converse is, and this is kind of just the nice little way of defining it in this problem, it is where you switch the condition and the conclusion. So it's if B, then A. So to kind of see it in more words, Here we have a straight angle is an angle whose measure is 180 degrees, and we want to write that in conditional format, which is if then, and then we want to write its converse. So my conditional is if an angle is a straight angle, and that was just based on a straight angle is, like the subject of that sentence is a straight angle. So, and then, so my conclusion is its measure is 180. Okay. So there's the conditional form, the normal if then. So my converse here is take the conclusion, make it the condition, take the condition and make that my conclusion. So if an angle angle's measure is 180. So you can see here, I literally took what I have there. I just put, instead of its, I put what it was, which was an angle. Then it is a straight angle. So the converse is literally switching them around, but you do want to make sure, especially like based on pronouns, you don't say what the pronoun, like I wouldn't want to say if its measure is 180, then it is a straight angle. You want to make sure you say like, oh, if an angle's measure, because we don't know what it is if we're put it, right? So basic English things there, but it's still important in math. All right, so there was kind of the basics of converse. There are other logic ones. So we're actually going to jump to page 23 in our notes, 1-23. And this is where some more of the logic comes in. So if A then B, write the following. So the converse is what we just talked about. So if B then A. Now the inverse is if not A. So if A does not happen, then B cannot happen. So then not B. Okay, and so if we're saying that something cannot happen, we'll put the word not in front of it. Okay, so that's the inverse. The contrapositive is if not B, then not A. Okay, and so remember, A was the condition or the given, and then B is the conclusion. So now they're saying if your conclusion didn't happen, then A couldn't have happened. Okay, and if you really think about that, if you're saying, okay, if A causes B, but B never happened, well then A never happened. And so that is a 100% true statement. So if a conditional is true, so if the if A then B, then its contrapositive is also true. For converse and inverse, they could be true, right? It is totally possible that if A then B is true, then if B then A, 100% true, and then also true if not A then not B, but they aren't necessarily true. Okay, where a contrapositive, if your original conditional statement is true, then the contrapositive is also true. Okay, so now we're going to talk about negation, which is that not. So in basic words, it is sunny. It would be it is not sunny. Fairly straightforward there. You guys use negation. Oops, sorry about that. Hit an arrow. You use negation all the time in just basic language. It's still a thing in math. Okay, so now let's go symbol. So if you have just P is what we're trying to negate. With logic, we use the tilde and then we say P. So this little symbol here, the squiggle, means not. Okay, so you can kind of see here in C, it's saying not A. Well, if you were to put not in front of that, you'd have two nots. And whether you're talking the English language or just math, two negatives make a positive. So if you're saying the negation of not A, you're talking A. Okay. So now that's important when we get some reasoning statements here and we're trying to form a full conclusion. So for this one, we're told that not P or if not P, then G. If E, then not F. P, not M, and then G goes to F. So with this, we have to also realize the contrapositive is also true. So that means for this first one, we know that if we switch the order and negate both of them, then that statement is also true. So if P, then G, or sorry, not P, then G, we'd have not G leads to P. Oh, I'm sorry, that is really ugly. Not G. And then we kind of work through this. So then we switch the order. So here, F would lead to not E. M would lead to not P. And then not F would lead to not G. Okay. So when you see this, having the four statements that we're just assuming are true because they're kind of telling us that, we also know the contrapositives are all true. Okay. So now what we want to do is we want to connect all of these into one big conclusion. Okay. So when I look at this, I see M and not M M only happens once. Same with E, right? So you have E and not E because of the contrapositive, but you don't have, so you see P is in this one, but then P is also in this one. We also have G here. We have G here. We have F here. We have, or not F there, but we have F there. So we're able to, because of the contrapositives, start with one of those two, either E or M, and go from there. Now, I see here I have E leading to something, so I'm going to start with E. So let me change colors here. So I can totally say, stupid smartboard. Give me a second. There we go. All right. So I can say, so I'm starting with E. E leads to not F. Not F, which is over here, leads to not G. Okay. Not G leads to P. And finally, based off this guy, P leads to not M. So I have all of this long conditional statement, which then means because this leads to this, leads to this, leads to this, leads to this, I can say from the beginning to the end, if I have E, then based on all of this, it would lead us to not M. And oh, that's not what I wanted to do there. And that is our answer. We could have done the same thing starting with M, and it would have been basically the big old contrapositive of this whole thing. So it would have been M to not P to G, G to F, and then F to not E, and that would be the other answer that is possible. Okay. All right, so go ahead and take a second. This one's got 6 of them, which means you have technically 12 statements because you have the contrapositives too. And go ahead and try out number 5 using the same logic. And yeah, take a second, pause the video, and then I'll tell you the 2 possible answers you could have gotten. Okay, so the 2 answers are either T goes to N as your first, so like in the previous example, right? So from here to here. Or the other one could have been not N leads to not T. Okay, so if you got either one of those 2, you did this 100% correct. If you didn't, go back and look through your work. All right, so now we're going to go back a few pages, and this is more so just talking about probability now. So switching a little bit of gears, but probability is something that will come up pretty often in this class, and future math classes as well. So probability is the number you want over total number. That's breaking down probability to its basics. So, and that's number of possibilities, right? And then it's over total possibilities. So for number one, if two of the angles are selected at random, what is the probability that both angles are acute? So there are ways of doing this, a few different ways, but because we're just kind of starting off with this, I'm going to just tell you, list out all the possibilities and then find the ones that are what you want, which in this case is both angles are acute. So I'm just going to start listing out all possibilities. So there's AB, AC, AD, and AE. And by possibilities, I mean all pairs, because we're doing two angles at a time. So there's all the pairing with A. Now for B, I already have B and A, so I'm just going to start with BC, BD, BE. And then go to C. Again, I already have AC and BC, so I'm going to go CD, CE. And then the last pairing is DE. So just looking at this, I know there are, if you count them up, there are 10 total pairings. So that means there's 10 possibilities. Now I have to just go through and check where they're acute. And remember, acute means less than 90. So if we start looking, A and B, less than 90. A and C, nope. A and D, no. A and E, good. So there's another one. And then we're done with the A's. So now we move to B, BC, BD, BE. BE is good. And then anything with C is not going to work because those are 90. And then anything with D, also not going to work. So all of those options don't matter. Sorry, again, I hit the button. So then we have 3 possibilities here, which means our probability is 3 out of 10. All right. So again, that's if you're unsure what to do, just write out all the possibilities, count out how many you have, and then count how many actually are what you're looking for, and then put the number you want over the total number. Now, the next 2 questions are kind of just in general. This always throws students off. So what is the smallest obtuse angle? If you're thinking to yourself 91 degrees, you are incorrect. The smallest obtuse angle is 90.0 repeating followed by a 1. Right? Because it's as soon as you get bigger than 90, which happens decimally, well, basically instantaneously, you have an obtuse angle. Okay, so now with that in mind, the largest acute angle, 89.999999, right? You just keep adding a 9 and you have a bigger acute angle. So you would just keep adding 9s forever, and that would be your largest acute angle. Okay, don't forget decimals. Happens all the time. People do it. Don't forget decimals. Okay. All right. So then the last page that I want you guys to try out here is 1-19. So this is some probability practice. And yeah, it's very similar to what we just did. What I would do, so the nice thing with the last page is all the angles were labeled already. Here I would just say, oh, I have A, B, C, D, and E as far as the angles go. And then you can literally use the exact same thing I just did on the last page. It's the same little chart. Figure out where both would be acute, both would be obtuse, both are right, and both are multiples of 30. And, write them how many there are divided by the total number. And then also try E as well. Okay. And then, go ahead and try 2 as well. The answers are up on Canvas. So when you're done, try those or check those out. Check out the answers. And thanks for watching and have a good day.